Okay, they want to determine whether the function is continuous at x equals 2, and if not, state the type of discontinuity. It is so much easier to see this if you graph it. And so I grabbed my graphing calculator and I typed in that equation, and this is what I see, something to this effect. And then over here, something like that. It's not the best graph, but there it is. Okay. The original function, which is 4 minus x squared, that is a difference of two squares. So I can factor that to be a 2 plus x and a 2 minus x, because if you FOIL it back, this right here gives you that. And then the denominator, which is x squared minus x, I can factor out an x, which would leave me with an x minus 2. And then if you remember, I had a problem earlier where I think it was an x minus 9 over a 9 minus x. Subtraction is not commutative, because like if you have 8 minus 5 over 5 minus 8, that's 3 over negative 3, not 3 over positive 3. In either way, it becomes 1. Because if you have 8 minus 5 over an 8 minus 5, that's 3 over 3, which is positive 1. But when they're reversed, you get negative 1. So I can cross cancel out this 2 minus x with that x minus 2, but ultimately I get a negative 1. So it makes this fraction negative. And so what I end up with is a negative, a 2 plus x over an x, and actually this negative is like out level with the fraction. So it's a negative 2 plus x over x. And now I can see that my denominator can't be 0, because if you were to stick a 0 there, you get an undefined function. So you can see from my graph that my y-axis is an asymptote, and the left side of the graph comes along and then turns and shoots up the side of it, and the right side comes and then turns and shoots like that. So in theory, this one is getting closer and closer to positive infinity, and this side's getting closer and closer to negative infinity because they're going in those directions. So it is not continuous at x equals 2. Let's see. X equals 2 is right here. And yeah, x equals 2. Oh, that's right. There's a hole in the graph too. Sorry. Let's see. If you look at this guy right here, okay. When you factor out the x right here cannot equal 0, but x also cannot equal 2. And when you're at 2 on that graph, there should be an open circle right here for whatever the y coordinate is. I don't know. So because of that gap, there can't be, but it's part of this side. So this side is approaching it to that point, and this side is approaching it. It's not jumping anywhere. It's just approaching an open circle. So that is, it's discontinuous because of a removable value of x equals 2. Let me go back to Mobius and see what it shows me. Okay, the function is, you got a drop down box. You either say it's continuous or it's not, and I know it's not continuous because it has a hole at x equals 2, and then it says there is no discontinuity at x equals 2. There exists a jump or exists a removable, and it's the removable on this one. So there you go. Okay.